Hello and welcome back to the course on deep natural language processing, and today we're talking about classical versus deep learning models. So let's have a look. As we discussed, we've got this diagram, and on the left we've got the natural language processing models overall, and on the right we have the deep learning models overall. So their overlap is the deep natural language processing. Those are the very advanced types of natural language processing models which use deep learning. And then finally at the bottom here, we've got the sequence-to-sequence models, which we'll be interested in at the end. And so I thought that this tutorial would be fun if we had a look at a comparison between a couple. So we'll look at a couple of examples from here. We'll look at an example from here, and then finally we'll mention the sequence-to-sequence, just to kind of lay out the playing field so we know what we're dealing with and what types exist there, because we could definitely just jump into sequence to sequence and look at the most powerful things, but then it would still be a mystery what are natural language processing models, how are they different to deep natural language processing models, and how are they different to sequence, what are the applications, and so on. So let's have a look at a couple of examples. All right. Some examples. We're going to have our diagram on the right, and we're going to start going through these examples one by one. So number one is the if-else rules, and this is a way that we used to create chatbots back in the day. So if-else rules are located over here on our diagram in just the NLP part, and what they entail is a huge list of possible questions and answers to those questions. And so once somebody in the chat asks a question, or we can identify that part of the sentence is the question that we have pre-recorded, then we will give them the correct answer, the answer that is associated with that question. But as you can imagine, such a mechanical approach to answering questions or chatting with people does not result in anything human-like, anything realistic, and it results in something like this rather, where you have questions and then you have the predetermined answers, but people want something tailored to them, something specific. They're asking about something else, but it doesn't fit into that list of questions and answers, and it just very quickly becomes a mess. But that's how we used to create chatbots. The next type, or the next natural language processing model we will look at is called an audio frequency components analysis, and it's used for speech recognition and sits over here. So we're specifically looking, we're purposefully looking at different examples. So not just chatbots, we're looking at different applications. So you can see that NLP can be applied to speech recognition, and there used to be, or still are, algorithms that use non-deep learning methods for speech recognition, and one of them is audio frequency components analysis. So in essence, what happens is we look at the sound wave of somebody talking, some pre-recorded or real-time audio of a human speech, and then we try to identify what waveforms exist in there. So in a very kind of simple way of explaining it, let's have a look at, for example, here we've got a Fourier transformation, and we've got there's our frequency over there, so it's like one of these is going over there. Of course, this doesn't even look like human speech, to be frank, but the concept stays. So like we look at what frequencies it consists of, and then we compare them to like the pre-recorded frequencies. So we know that, for instance, certain combination of frequencies means this type of word or this type of word. And it's not just about the frequencies. Of course, it's much more complex than that, but this is a very general overview of what happens. We look at the frequencies, certain mathematical operations. This is the key point, that we're not doing any neural computations. We're not creating any neural networks. We're just doing mathematical calculations around the frequencies that we can observe, comparing them to the mathematical calculations we have in our library of pre-analyzed frequencies, and then we're matching it up. We're finding what word the person is saying, what question they're asking, or what the sentence is meaning, and then that is how we recognize speech. So there's another version of natural language processing, which is in the green area. Next one is the bag of words model, which is used for classification, a very, very popular approach for text analysis or natural language processing. And what it does is basically, well, it also sits in the NLP part, in just the green area. Although, as we will see further on, it can sit both in the green area and in the purple area over here. But that's something for a later discussion. What the bag of words model does is, there's our bag of words, and the way it works is you might have like lots of text. For instance, here we've got tutors or lecturers or examiners who marked grades, so who gave a pass or a fail grade to different papers or different assignments that were submitted, and then they also left a comment. So somebody said great job and left a comment of 1, meaning a pass. Somebody said amazing work, left a comment of 1, well done 1, very well written 1, and then poor effort 0, could have done better 0, try harder next time 0, and so on. And so from this, what the bag of words model will do is it will put all these words into a bag, and it will remember, so how often does the word great come up with a 1, and how often does the word great come up with a 0. This is again a very general explanation, a very high level explanation of what happens, but in essence this is the concept, that it will look at the words and it'll try to classify these words. It'll try to associate these words with either positive result or a negative result in our case. And so in this case, like amazing would be most likely associated with positive. You don't often see amazing when you're trying to say, when the sentiment is negative, when the person was trying to say something like the work wasn't well done, or well would be associated with one. Like the word work could be associated with both. But then these other words, they would be mostly associated with pass. Some like words like poor or harder or could have, maybe would be associated with zeros. And so then it'll remember that, it'll keep these words in a bag, and next time something comes up, for instance, somebody says, good job, keep it up, or something like that. It will analyze the words that are in that new sentence by pulling them out of the bag and looking at them and understanding, are they mostly associated ones or zeros, and then it'll be able to predict, it'll be able to classify the new comment even without knowing what the mark was, pass or fail. It'll be able to say, based on the comment, it'll be able to say, is it a pass or a fail? So that's like a very simplistic application of the bag of words model, but there's another one, an NLP model. Okay, so let's look at a deep natural language processing model, and this one is going to be located over here. It's called convolutional neural networks for text recognition. So the model we're going to be looking at further down is indeed a deep natural language processing model, but I wanted to give an example of a different model. So not just the one that we're looking at, but like also a deep natural language processing model, but a different one. And one I came across is when we use convolutional neural networks for text recognition and then further for classification. And so if you're familiar with convolutional networks, or even if you're not, what they're used for is, it's a neural network that is used for mostly image recognition, for like videos. Self-driving cars use them to detect obstacles on roads, people, and so on. So mostly it's used for image processing or video processing. And so it is very interesting to see how convolutional neural networks can actually be used for text processing. And the way it works is these words are transformed into a matrix, and that's done through an operation called embedding of words. And then once they're in a matrix, the same principles as convolution, as we would apply for images in convolutional neural networks, are applied. So there's a convolution operation going through these images. Then they're pooled, max pooled, or min pooled, or sum pooled, and then they're flattened, and then we have the prediction. So we won't go into detail right now of how convolutional operations work. There's lots of tutorials out there and so on, and it's just not in the scope of this course, because in this course we'll be looking at mostly recurrent neural networks, which is RNN, a different type of neural networks. But I just wanted to put it out there that you could technically use convolutional neural networks for text recognition just as you would do with images, and very interesting concept. It was one of the earlier ones that was explored, and then we moved on to recurrent neural networks, as we'll see down the track. So there we go, that's another one. And then finally, the main model that we'll be looking for, working with sequence to sequence, has many different applications, as we'll see further down, and that's the one that's over there. So I'll give you a short preview of what's coming up. It looks something like this, and don't worry, it might look very complex right now, but in a couple of tutorials from here, we'll be very comfortable with what's going on here and how this whole construct is working and why it's called sequence to sequence and what exactly it allows us to do. So there we go. I hope you enjoyed this quick overview and comparison of the different types of models and different applications that they have, and we'll continue next time. I look forward to seeing you there, and until then, enjoy deep NLP.